Well, good afternoon and happy Monday, everybody. Welcome to the Endless Studios live stream for July 20th, 2020. I'm Brian, and with me, as always, is Natalie. Hello, Natalie.
Hey, what's up,
How
Brian?
was your weekend?
It was good. I mean, obviously, it's really hot here in New York City, so I tried to take it easy and, not overheat, and I succeeded in doing that by playing some video
What
games.
video games did you play?
So I've been having a fun weekend because my stepson is in town, and we played Ultimate Chicken Horse.
That's a good one. Very
Yeah,
game designy game.
I know. Build your own level and then play it,
Mm-hmm.
right?
Mm-hmm.
Yep. So what about you? How was your weekend?
It was pretty good. It was hot here, so we spent the most of the weekend in various pools, which was a good idea, I think.
Yes. Always a good idea.
Cool. So we are going to get started on today's stream and spend the majority of the stream, I think, Natalie, continuing our VR shooter implementation. We got out of our pre-production phase last week. We'll talk a little bit about what that means and where we're at. Just the usual info and directions for folks watching the stream. Let me try that again in English this time. If you are a participant in the Endless Studios summer program, please hop on the chat and say hello. Let us know that you're watching. Let us know if you can understand what I'm saying as I sputter sentence fragments and things that are not English. And let us know what's going on. Certainly, if you have questions about the course or anything that's come up, now is a great time to ask them, and we'll be happy to answer them. But as I said, we're going to spend most of our time working on the VR shooter implementation today. So,
Absolutely. Yeah.
actually, in that vein, just to orient everybody, I'm going to bring up in 1 second here when I find it.
I see Ms. Rogers in the
Hey,
chat.
Miss Rogers. Hey,
Hey,
Ronan.
Ronan is there. Hey, guys.
All right, let me do this just so we have a little
I
reference.
saw Ronan had posted a game, I think, in the playtesting. So
Yes,
glad to see more projects rolling
it is
in.
good to see projects rolling in. We gave Ronan some feedback, I know, and hopefully Ronan will be ready to move on to the next unit, which is awesome. Okay, so let me share some screens here. So this is our little just visual of the game making process. On our VR shooter project, what we did last week was we did our pre-concept and our concept phase. So we gathered a bunch of information to help us make decisions about what we wanted to do with our mod. Then we made some decisions and we put a plan together about not only what we were going to do, but the order we were going to do stuff in. And with that work being done, we officially, on the end of our cast on Friday, said we have officially moved from the pre production phase to the production phase of our mod. So now we've transitioned from thinking and planning to actually doing stuff, and that's what we're going to start in on today. Now, because we're working on a mod, a lot of these individual steps, like first playable, alpha, beta, they don't necessarily apply in this sense to a mod because we're not implementing something from scratch. We're going to be kind of adding things system at a time, testing them system at a time, rather than working towards a cohesive milestone like you would on making a full game like a first playable or alpha or beta, which are all things, Natalie, we talk about in the course.
Yep, yep. Yeah, and I'm glad you brought that up, Brian, because I just wanted to clarify for the folks that are listening in that you can use this process even when you are making a mod or a game system within a game, and you just use the parts of the process that are useful to you. And I think that for this, what's really useful to us is the notion of doing pre-concept and concept and then production. And because we're working on a mod for this version, we're not breaking production down in as fine-grained of a way as you would if you were making a full game. But, you know, doing that step-by-step process is incredibly useful for us, even whether or not we're on the macro scale or the micro scale of development. So yeah, I just wanted to say to folks, like, you're probably looking at this like, doesn't this mean that you would always start from scratch at the beginning? And the answer is no. This is a development process you can use like on any layer of the game making spectrum. I guess spectrums have layers, right, Brian?
If they didn't before, they do now.
That's right.
Cool. So that's kind of where we're at now. In terms of our specific mod, I have our notes here. Natalie, I did a little reorganizing of this to kind of get things in the order. So if you remember, we sort of decided on an arcadey theme to our mod. We want to make our mod make this shooter game a little more arcade-like, arcade game-like in its character. And so we came up with a set of features we were going to do to make that happen, and the order we were going to do them in, because as we were laying out the features, we quickly realized there were dependencies that some things had to be done first so that we could build or mod a system that another feature was going to need. And so things kind of laid out in a certain order pretty naturally. We didn't have to do too much finagling, Natalie, to make that kind of fall in line.
Yep.
Um,
Yeah,
so
this looks good.
so we're going to start today with adding into the very basic framework of how things like the weapons work, um, the crits and multipliers concept, the weapons and the timer, so that we can have critical hits and we can have multipliers on our score. We want to get the base support in for that. And as I mentioned last time, we didn't have to start with this, but of the things we could start with, I chose it because I think it was relatively straightforward and will be a natural way to introduce some key Unity concepts we're going to use throughout the implementation. We then realized we gotta hit our enemy wave system pretty hard and get that working, because everything else that comes after it depends on it to varying degrees. So before we can have the boss, before we can do the rest of our crits and multipliers work, and before we can have the Smart Shield UI revisions that will display, your current state and what wave you're in and stuff like that. To do any of that, we need to actually have the basic wave stuff working first. So that's why we're going to start with our wave system.
Sounds like a great plan.
So that's the plan. So we're going to work on crits and multipliers today. And so with much ado over with, and without any further delay, we're going to go right into Unity, which I'll bring up here. And start.
Yay, we're finally there.
We're here. And you guys did get a little preview of this because I think we did some of the demoing and playing of the unmodified VR game in Unity. But now we're in for reals Unity, and we're going to start working on that. But before we can actually start working on it, that was such a tease because I'm not actually going to do it now, Natalie. I'm going to mess with people.
No.
Before we can actually start doing that, a brief tour of the Unity development environment is probably in order. And again, my goal here is not so that you will memorize every single thing or take a vocabulary test on what stuff is called. So I'm not going to go into exhaustive detail here. I want you just to be able to understand when I throw around terms like hierarchy or inspector or script. What I'm referring to, and to know where in the user interface that stuff is, and just sort of be level set on that stuff. So I want to do a bit of that, and I'll do a bit of that up front, and then I'll do a lot more of it in the context of doing that implementation of the first stuff we need for the crits and the multipliers. So we are now in the Unity editor with our project loaded, right? So if you've ever done any kind of software development before, some of these concepts will be familiar to you. So this is an editing environment, and it's a visual editing environment for editing your game. Your game is organized as a project, which contains all of the materials that are used to make your game, to develop your game. So everything in a Unity game lives inside the project. That's everything from the individual levels and how they're laid out to all the assets and the 3D models that make up the world, to your game's code, to what other kind of stuff am I missing, Natalie?
Audio is an option
For sure.
there. The clouds in the background that you can see in the main window, we call that a skybox. You can find that in there. If you use images in your UI, you might find some sprites, which is like a flat image. like you see on the web, um, which corresponds with, of course, then you said there's 3D models in there as well. So lots of visual things.
Yep.
Um, yeah, I'm trying to think what else. Sometimes there are certain things in there that are specific to the game. You might
To
download
your
like a
particular
whole
game.
system.
Yeah.
Yeah. But those, I think you've covered a lot of the general things that show up in every Unity project.
So the main thing to remember there is everything that is, and I'll throw this term out there, an asset, asset that you might use, and easy for me to say, that you might use in your project, an asset in your project, uh, at some point becomes is represented here. And if you were to look at the structure of this project as it's saved on my disk, it's organized into a hierarchy of folders, just like any other folders you would use on your computer to store documents. And this hierarchy of folders ultimately gets represented, or part of it does, inside the Unity user interface, um, in this panel here called the project window, right? So that's what you see over here in the lower left-hand corner of my screen. And this is fundamentally representing every asset that's available to me in my project. Now, again, that might not be an asset that's on the screen right now, up here that you see in the scene window. It might not be an asset that's in this level at all. But if it's an asset that I can use in my project, it's here. And if I want to use assets that aren't in my project right now, I would bring them into my project by importing them.
Yep, exactly. And the thing I like to say about assets is it's everything that could go in your game. So if you think about, and this is always true in most software, and it's a thing we explicitly focus on in games because you can use a lot of different file formats in a game, but you can't use any file format. So if you think about a graphics program, the only file formats you can use are graphics formats like JPEG, PNG. Similarly, in Unity, we only have certain kinds of files we can use. And it's just so nice because it's all grouped in this subfolder that is your project. And then that folder is broken up into even more subfolders that are organizing your various audio, 3D models, etc. And that prevents you from trying to put something in your game that wouldn't work in this program.
Exactly. Unity projects um, and Unity developers tend to follow certain ways of organizing their assets, organizing all the stuff that's available for you to use in your project, right? Some of that is just sort of a convention we all follow to keep things organized. Some of it actually has special functions in Unity, and we'll talk about some of those as we go through. But if you look, right now we're looking at the top level of all the assets in my project. That's what's up in this project window right now. And you can see the folders here have very logical names that correspond to the high level types of things we can have in the project. So there's a folder for fonts. And if I click in on that, these are the files that contain the font definitions for all the fonts I'm using in the game's UI to give it the appearance that I want, right? Um, models Natalie mentioned, these are the 3D models that get used in the game. There's this folder's got the ray gun, this has got the drone itself, this has the shield, and this has a bunch of the assets. This Sky City light is a set of assets that I've used to create the environment. Materials, we'll talk a little bit about materials later if it comes up. Basically what you need to know is materials are the kind of things that take a raw 3D or 2D object, right? So that's just defining its shape or its geometry, and they give it its appearance, its texture, how it relaxes, its color, how it reacts to light, all of those things. You typically model something and then throw these things on it to give it the visual appearance that you see. So models relate to materials, but they're slightly different. I'm gonna.
Yeah.
I'm sorry. Go ahead, Natalie.
I was going to say those are really complicated to explain, but my extremely broad understanding of them is that they're kind of like wrapping paper that goes around kind of if a 3D model was just like it's digital clay that's been formed into a shape, and then you put wrapping paper around it to give it a look. it's different than wrapping paper because we have an immense amount of control over what it does and how
Yeah.
it looks and how it reflects light, but it's a material is like this like thin layer that goes on top.
Yeah, and just a quick example of that would be if you think of literal wrapping paper, when you buy a roll of wrapping paper, the pattern on the wrapping paper, so what's visual appearance in terms of what areas of the wrapping paper are what color, right? And how glossy the wrapping paper is, right? How reflective of light it is. That's sort of baked into any roll of wrapping paper that you buy. They sort of come together as a package. But in the 3D modeling and game making world, those and many other things can be separate. So I can define a material's uh, texture, its color pattern type appearance, and it's how reflective it is separately, right?
Yep.
And among other things. So that's
Yep.
materials. I'm going to skip over what prefabs are for now. That's an example of a special type of object in Unity. We're going to make use of those, and when it comes up, I'll talk about them. I'm going to skip scenes for just a second. Scripts are where most of the, if not all of the code of your game live. We're going to talk a lot about that probably a little bit later today. SFX, short for sound effects, that makes sense. And then these two folders, these Steam VR related folders, Steam VR and Steam VR input, are an example of something that Natalie mentioned before. We know this is a VR game. And to make all the stuff in having to do with VR work in the game. Not surprisingly, I didn't code that all up myself from scratch. Instead, I'm using a framework. It happens to be the VR framework published by Steam. Good old Steam, where you buy games made by Valve. They make it freely available for developers to use, and I'm using that framework. So at some point, I imported the stuff from that framework into my project, which allows me to take advantage of it anywhere in the project I want to. Now,
Yeah.
go ahead, Natalie. I'm sorry.
I was gonna say, I just wanted to point out that this thing that you're showing right now exists in most game making platforms you will use.
Yep.
It is just a little bit less, like this looks very much like a real computer, right? Because Unity is this advanced tool. But, we see this project in GameStar Mechanic. It's on the left where we see all of the different sprites we can pull in GameStar Mechanic.
Yep.
And then in the Endless Mission, we see, again, a little bit more user-friendly version of this. Oh, you know what? On GameStar Mechanic, it's on the left.
It's on
And
the left. Yep.
yep, and in Endless, it's on the right.
Correct.
And then in Unity, it's in the bottom in the way you have it laid out right now, which is pretty standard.
Yep. Yeah, and I should mention you can lay out your windows in Unity any way you and customize it any way you want, including having if like me, normally you have a setup where you have multiple displays on your computer. You can have some windows on one display and some on another. I'm using the most standard sort of Unity layout here, slightly modified, because I think it'll be relatively familiar and it keeps everything on one screen that fits nicely. The scenes folder is a special kind of folder in Unity. A scene in Unity is more or less, this is a little bit of an oversimplification, but it's more or less a level, what you would think of as a level in a game, right? That's shorthanded and it's an oversimplification, but it's a useful way to think about it, right? So in a typical game, you might have as many scenes in your game as you have, if not levels, at least distinct environments in your game, right? So for example, in our game Beyond Blue, which is, our undersea ocean exploration game, there are something like 15 or 16 distinct levels in the game that you progress through. Some of them you're underwater swimming around in your wetsuit, and some of them you're back on your submarine in between the diving levels doing stuff. But there aren't 15 or 16 scenes in the game. There's one scene per distinct environment because you revisit the same environment multiple times, right?
Yeah.
And we change, and the scene has the data for that all of those multiple times. And then when you load that scene when you're playing for, okay, it's the time we're loading that in what you would know as the player as level 5, the game knows how to load up that scene with the appropriate settings to make it look the right way for level 5.
Yeah. And this is, I'm glad I just said that other thing about the other platforms because, this idea of a game level being a file in the project, that's very much something you see in Unity and is not as clearly represented in some of the simpler platforms. Um, like if you're using the endless mission, you're probably just working on one level at a time, and you're not going to build a big game project with multiple levels. GameStar, you can do that, but you don't see it as a file. And so this is a uniquely powerful concept that you have access to when you finally graduate to Unity. And it requires a little bit of thinking to understand how it works, because instead of like thinking that you've entered into the game world sort of like in this all-encompassing realm that you're now in, you start to think of each level as being this sort of like a 3D document that you're building, and you have a file folder that contains all of those
Yep.
levels.
And again, your game can have many, many scenes in it. In this case, there's really only one scene. This thing called sample scene gets created by Unity automatically when you start a new project, and I just never bothered to delete it. Um, this the one functional scene in this game, because there's only one level or one environment that you're in, is this VR shooting gallery scene, which is the one we have open right now. Now, when you play a game, a Unity game, one way you can easily tell when you're transitioning between scenes is that's when you would see a loading screen, typically in a game, because loading and unloading different scenes. When at playtime you can only have one scene of the game active at a time, and so that's why you have loading and unloading of scenes, and you have loading screens.
Yeah, it's a little back door into the reality of game development there that you can start to see when you're playing.
So that's a quick look at the projects window over here. And you can see, I've got that organized in folders that I can view over here in this rightmost panel. I've got it as sort of a hierarchical view where I can expand things and look at different things, and that'll affect what's in that panel. And I've even got some search features and filter features here, so I can find specific things in my project. That makes it really easy to do that. So that is the project window. But now let's focus on the top part of the screen. So this window setup I've talked about before. I talked about it when we previewed our game. Up here, the nice graphical window in the upper center portion of the screen is called your scene view. So with this active scene, the one real scene in my game loaded, this shows me the layout of that, in this case, 3D scene, right? And as I think I demonstrated before, it's possible for me to navigate around this scene. I can, look anywhere I want to with my camera. I can kind of zoom around the scene using holding down on my right mouse button and hitting WASD. I can zoom in or out with my mouse wheel, and that makes it possible for me to look around the game world and see anything I want to see. Both the physical, tangible objects in the game world, like this light, let's say, which we also see when we play the game. But then there are often iconic representations of things that you don't see. So, for example, this little icon that looks like a speaker icon, I know that tells me that at this location that I'm looking at in the world, there is some audio source, something emits sound that's in this location in the world, right? And that's what that icon means. And I think what that is one of the, if you remember from the gameplay, one of the portals that the enemies spawn from, there's like a little whoosh sound effect when the portal is active. And I believe that's the audio source for that sound effect.
I think that's right. Yep.
And that's how the scene works. Now, one thing you'll notice as I move around my view, I pan my camera around in this scene, is you will see in the upper right hand corner is this thing called and we call that the gizmo. and it is a representation of the three axes. And I'm sorry to be all geometry class right now, but this is super important and super common in any 3D game making environment. Um, the world is represented like a three-dimensional grid, right? The term for those of you in geometry class that you might be familiar with is a Cartesian plane or a Cartesian grid in this case because it's in 3 dimensions. And so it has an x, y, and z axis, right? By convention, the y-axis is the up-down axis in the world. So something that's high up is high on the y-axis, or low down is low on the y-axis. And then the x and z axes are your left, right, forward, back axes. So and then as I move my camera, the gizmo moves with me, which tells me how my camera is looking relative to the x, y, and z axes of the world. And so right away we can tell, in the case of my game, the way this level is laid out, this scene is laid out, is, as is usually the case, the y-axis is the up and down axis. The x-axis is sort of the left-right axis of the way the level, this platform that I'm on, is laid out. So it's relatively narrow, the game along this x-axis. And then if I rotate so we see some of the other way, the long dimension, the long bowling alley thing that we're looking down, is aligned with the z-axis of the game world.
Right. And one thing that when I first learned about Unity, got confused about with this is that's the X, Y, and Z axis of the whole world. So that doesn't change because it's just set in the world. But each object in the world has its own X, Y, and Z axis. And that can rotate and move around in comparison with the X, Y, and Z axis of the world. So that one up in the corner is just hard set by the universe of the scene, as the X axis is just in that direction. And that gizmo is there to help you automatically see. Of course, it's arbitrary that the X axis or the Z axis goes in that direction, but we had to pick a direction it went in the scene. And that arbitrary direction that was decided upon is reflected up there, so you're never confused about it.
Yeah, and thank you for bringing up that point, Natalie, because it is something that I think confuses folks, right? But for right now, what I want you to focus on, and the difference between the global XYZ axis, which is known in, you might hear the term, we're working in world space, the space of the world, or the world axes or axis, right? Those are like the official, this is what the world is based on values. And then an individual object has its own local, can have its own local X, Y, and Z axes as well, right? And a way to think about that is, if you imagine you dropped me, right? You dropped a human being into this game world, or a 3D model of a human being into this game world, right? If you drop me in and I'm standing up, my y-axis is is equivalent to my height. Let's say that my x-axis is my width and my z-axis is my depth, right? And human beings have some depth.
Yep.
You're not perfectly flat. You have some depth, right? And if I'm standing up, those three axes would, in a normal way, facing the same way the camera is facing right now, I would be perfectly aligned with the axes in the game world, right? My x-axis would be the same as the games, my y the same as the games, and my z the same as the games. But that doesn't have
Yep.
to be the case. Imagine if I lied down, right? So I lie down flat on my back on the ground of the game. In that case, now my local y-axis, Brian's y-axis, is now aligned with the game's z-axis, right?
Yep.
You can have, and of course, to keep that example simple, I made them perfectly aligned, but there's no reason I would have to lie down right along the z axis, right? I could be rotated relative to it. So there's those things don't necessarily and frequently do not match up, right? And we don't want
Exactly.
them to, often for good reasons.
Exactly, exactly. What I always think of, and this is just broadly true in the way like a video game avatar is set up in in well-made avatars in any case. The Z is always just this like blue line that's just like sticking out of the front of the avatar.
Yep.
And it can be really helpful when you're doing game programming to think of that blue line sticking out. And if I want to rotate the avatar for some reason to line her up with something, I might be like, okay, whatever I line her z-axis up with, she's going to be facing
Yeah,
that.
and there are guidelines for good construction of models that follow that, right? You want to keep the y-axis being the up-down axis, and importantly, you want the up direction, right? Because we haven't talked about this yet. We want the up direction to correspond with what is up for that object. So if you built the 3D model of Brian, but the up direction in the y-axis was pointed at my feet, it was pointed down,
Right.
that would be bad, right? We want it pointed up. And
Ugh,
similarly, that z-axis, right, Natalie, the blue z-axis, we want that pointing forward from the avatar's perspective, right?
yeah. I've
Um,
seen some really bad assets where people didn't do that correctly. And you bring them into that project window down there at the bottom. And, one of the cool things about Unity is it'll give you a little visual preview of everything you've pulled in. And you'll see all this like furniture that's like turned on its side in the preview because they had the y-axis sticking out of the side of like a dresser instead of the top. And I think in the preview it always displays it with it having the y-axis up in the preview,
yep.
and you'll see it come in and you're like, why is everything on its side? That's so weird.
It's the bane of our existence when we
I
when we use
know.
models that someone else has created. So,
Yep.
another thing to point out about this world system is just like if you think about a 2D, to keep it simple, a 2D coordinate system, Cartesian coordinate system, maybe that you remember from math class. This world works exactly the same way. So, except with 3 dimensions in our case, not two, because it is a 3D game. So just like you could plot a point on your 2D by giving the x, y coordinates, right? You could say, 2 units on the x-axis, 7 units, 2 comma 7, 2 on the x, 7 on the y, and plot that point on the grid. You roll. I'm imagining that and maybe having a little post-traumatic stress from geometry class, but you can imagine doing that, right? Similarly, in Unity, we can talk about the positions in our world using their 3D coordinates. So we can say something is positioned at, X location 3, Y location 10, Z location -7, right? Because there's positive and negative too, right? And in the case of the Z, 7 units would be in the forward direction, right? The down the alley direction, but negative would be in the opposite of that, right? And there is, just like on the Cartesian coordinate system, there is an origin point for the entire game world, the 0, 0, 0 point, and things go positive or negative from there, right? And we can define a thing's position in a Unity world by specifying its x, y, and z coordinates. By convention, and you don't have to do this, 1 unit in that system of distance, right? So if you say I'm at x, 1, y1, z1, y comma, 1 comma 1 comma 1, right? By convention, when we make Unity games, we say 1 unit in that system should equal 1 meter in the real world, right? You don't have to do that when you make your game. There's no law that says you have to do that. It's just something that we follow, and most Unity developers follow by convention, that 1 unit in the Unity coordinate system equals 1 meter. So if I say, this thing, if I were modeling a person, right, I would want them to be a little, of average height. They're a little less than 2 Unity units on the y-axis tall, right? If I want to
Right.
preserve that scale.
Right. And I mean, it sounds arbitrary because like you can just pull things into that scene and size them the way you want. But if you're building something that resembles anything in reality, that is so helpful to know because you can just build it off of the real sizes of things rather than just trying to eyeball it.
Yep.
Because like you could make the avatar be 10 Unity units and then have everything else correspond with that visually, but you're going to get into all kinds of wackiness when you just eyeball things rather than setting the numbers up correctly from square one that I have experienced. And what happens when you do it that way is you look at the scene, it looks wrong, and you can't figure out exactly what's wrong. It just doesn't look real.
Yep. And again, sticking with that makes it a lot easier in just every way, because if you're trying to, as Natalie says, model something in the real world, it's very easy because often the size of things in the real world, you can actually find how big they are in meters, or if they're not listed in meters, you can do the math to convert from, feet to meters or whatever, right? So, if you're making a sports game and you want to model a football field, it's great to work in, a unit like meters. I was thinking of like a soccer pitch, not an American football, because we measure American football fields in yards, and we'd have to do a minor conversion there.
Ugh.
But if you think about a football pitch, modeling it in meters is super, super useful, right? If you,
Yep.
and it's also useful when because then anytime you use physics and you use movements, you're already naturally working in meters. And so you can say, oh, this thing is moving at this many meters per second, for example, and you're already working in that. And you can say, well, how many meters per second does a car move at, right? Traveling at 30 miles an hour, and you can do the math and do that conversion and have a reality check. So working in real world units is a good idea. And indeed, that's what we do in this game. So you can, in this game, as we work on the project, and if it becomes relevant, we know that 1 unit is equal to 1 meter.
That makes me think, Brian, it's never occurred to me to do this because we don't do as many first person games. But, it makes me curious how many meters per second a first person controller goes because I feel like it's got to be like the speed of a car, you
Well,
know?
yeah, and different games have that at different fields, and I say that these things are um, at least can be realistic. They don't have to be, and sometimes you cheat because you find that something doesn't feel really good, right? Again, I think it's the example there. It's a little bit of a weird example, but I think someone has done the math where like if you take a Barbie doll and you say to be how tall would a human being have to have the like proportions Barbie, and like Barbie would be like 10 feet tall or something. Like, it's crazy, right? And so you can do cheats like that.
Yeah.
um but again, it's helpful to start somewhere, and certainly in this game I can remember when I developed it, things like how fast does a laser blast move when it flies out of your gun were based on real, like me looking up how fast the bullets move and things like that, right? And I may have done some fudging there to see what presented well, but it started with, well, what could that be based on? And again, that's often useful as a starting point, especially for something like an FPS, because so many games there are trying to model realistic combat, right? Down to, oh, you're playing this World War II game and you're really, you're wielding an authentic World War II M1 rifle, and therefore we want a round to come out of that rifle at the same speed it would have in the real world,
Right.
right?
I mean, the thing I was going to say too is like, I mean, I don't know about you, but my reality includes shooting at endless streams of evil drones.
Oh, all the
And,
time, yeah.
you know, but, in all seriousness, even in a made-up science fiction game, trying to have the bullet fly at a speed that resembles a real bullet speed makes it a better game, even if the occasion of the game is
Yeah.
imaginary. There are always elements of reality that you include and then elaborate on with your design.
Yep.
So, you can't just say with a game like this, oh, I don't think that this is reality, so I can do whatever I want.
So as you've been watching, we've been talking about this, and if you've been watching me navigate the world, I'm just sort of moving around. It actually feels a lot like, as I move around my scene view, I'm moving in a first-person shooter. And Unity does some things here. So, for example, you can see if I'm actually, all I'm doing right now to move is I'm holding down right mouse button and using WASD. And if I do that long enough, you'll see the movement starts to accelerate because Unity kind of figures out I'm trying to move a long distance here. As I do, it starts out slower and then it goes faster, right? There's no shortage of debate in the Unity developer community about whether that's a good feature or not, but I like it personally. Um,
I like it too.
so as you get into using the endless mission in the course, the movement system in the endless mission exactly the same. So you'll learn how to actually control the Unity movement when you do your endless mission coursework. So that was navigating around the scene. Now we know there's a bunch of stuff in our scene, right? There are all of these environmental objects. There is the player avatar. When they start spawning in, there are enemies. I talked about how where you see these volume or these speaker icons that's we can tell that's where certain spawn points will occur in the game. Everything in a Unity scene that is in the scene right now is represented over here in this panel in the user interface called the hierarchy. Hugely important Unity concept, and that is definitely a buzzword I want you to remember, is the hierarchy, right? Why is it called a hierarchy? It's called a hierarchy because all the objects are represented here, but they are represented in groups where there can be parents and children, right? Or a hierarchy. So this is just like if you imagine, uh, a tree, because the other name for this type of displaying things sometimes we'll hear is a tree view. You think of a tree and it has a trunk, and then there are branches that branch off that, and then there are branches that branch off those branches, and then there are branches that branch off each of those branches, and then eventually you get to individual leaves, right? Same concept here, viewing things in a hierarchy. I'm sure you guys have seen this type of interface in other pieces of software. Our Unity scene is organized into a hierarchy, and as a Unity developer, I can create whatever hierarchy I want to represent the things in my scene that I find useful. So you can see there are some things that are right at the top level of this hierarchy, and then there are some things that are grouped. An example of things that are grouped is the environment. Everything that is making up the environmental assets in the level, the floor, the lamppost, these display screens over here, the benches, and in fact, the spawn points, where those spawn points get placed in the level, everything that's about the geography of my level, if you will, I've chosen to put that into a group that's called environment. And if we expand this, you can see at the next level down, my environment is made up of a number of different platform segments, right? So these are each a section of this game's platform. And if I select one and you look at the scene view, you'll see the ones that I'm selected being highlighted. Right? There's the very first one at the start of the level, the first platform segment. And if I expand that, I can see everything that's within it. There are different sections of floor, and you'll see those getting highlighted as I do that, right? And I can expand those. And I'm not exactly sure how deeply this goes, but there are that's how my level is laid out. And in fact, when I built this, what I did, and it's an efficient way to build a level, is I built one small section, or I built a couple of different small sections. I arranged them in an order that I liked with different things in them, so I thought they looked cool. And then I just cut and pasted they formed a larger section. Then I cut and pasted those larger sections over and over again, repositioned them in the world, and that's how I built the basic geography of my level when I built it.
Yeah, and one of the cool things about that is if you wanted to even just duplicate that entire construction, now you can do that because duplicating the parent will duplicate all of the children in the exact structure that Brian has that laid
If
out
I wanted
in.
to do that, all I had to do is right click on whatever I want to duplicate and click this duplicate button, and I end up with an exact copy of this object, the whole environment, and all of the child objects or children under that environment.
Yep. Super useful for if you were actually building a tree with individual leaves, for example, because then you could be like, okay, I'm just going to duplicate the whole tree. I don't have to like reset the leaves up every time I want there to be a tree in my game.
Yep. Now, the other thing that's cool about the hierarchy is anything I select in the hierarchy, if I select something and I double click on it, the Unity camera will automatically move to give me a view of that thing. Now, what did I select here? I selected something called directional light. And now you don't see anything because a directional light itself is invisible, though you can see somewhat of an iconic representation of it here, because it's something that's positioned in the world but isn't itself a physical object. What is a directional light? It's exactly what it sounds like. It is a light source that is lighting our game world. And it is coming from a particular location and has a particular direction in which it's shining. You can sort of see that because with that object selected, you see it gets its own gizmo, right? So there are its Y, Z, and X axes represented by the green, blue, and red arrows coming off of it that represent how it is oriented in the game, right? And that's because I want the light effect to be shining in a particular direction. Directional lights are a very, I guess the technical term from filmmaking or game making or photography would be diffuse would be the term. They're very soft light sources. They light a big area very uniformly and very softly. And so in games, a directional light source is often used to represent the light cast by a faraway celestial object like the sun or the moon or whatever star it is in space that's lighting this level, right? And there are other kinds of lights, some of which may even be used in this game for all I know, that have different qualities to them in a game. So if you wanted to represent the light that a torch gives off, right? We use something called a point light because that's a more concentrated light source that gives off light evenly in all directions around it, right? Which is what like a torch or a candle or a like a lamp does, right? Like a tabletop lamp. If you want something that works like a spotlight, where the light is very directional and very strong and focused on a specific point, there's a spotlight for that, and so on and so forth. But in this case, the game has one big directional light that I'm using to sort of uniformly light the game level and create that overall lighting effect.
You know, one thing when I first started learning Unity and doing game development was I was just so surprised by how many details there are around lighting.
Yeah.
You know, it's a whole art, and there are some folks who work on big game teams who are lighting designers, and they work entirely on making the lighting beautiful. And you know, you see that in any kind of studio that does 3D work. That can be in a film studio that would do computer animation,
Yep.
would have lighting experts, and it's something you could really delve deeply into if you love the visual side of game making.
So that's an example of another object that's in our hierarchy. Some of these are pretty straightforward. The player, which I just selected, is an example of another object that's in our hierarchy. The player represents the player. And when I do that in this case, you'll see a bunch of things suddenly became visible in our game world and got selected in our game world. Now, even if I zoom in very, very closely, you will notice that with the player selected, one of the things you don't see anywhere is like a thing that looks like a human being or a space marine or whoever it is that might be defending us from all these drones. Why is that? First person game, right?
Yep.
In this case, we don't act, and in particular, a VR game. So in a VR game, the most you typically ever see of your avatar maybe are hands or the objects he's holding in his hands, as is the case in this game. You don't see any of the model at all, not even like the little bit of arm you might see in a FPS that was played on a screen, right?
Yeah. That's so disorienting too to think about because like it destabilizes your perception of what a game really is. Like I had this thought playing the game Portal, which in that game, there are times when you can see your own reflection, but then is that model really present in the game when you're not looking in a mirror? Probably not.
Yeah. And that's an important thing too, because having the avatar present in the game world, having a model for the avatar present in the game world means that the game has to keep track of its position and render it and do things like that, which take system resources. And so if you're not going to see it, there's no point in having it be there at all, because all you're doing is wasting system resources to not be able to see something, right?
Yeah.
Now, if we look at this player object and I expand it in the hierarchy, there are a number of things that we see. At the next level down, we get this thing called camera rig, because one of the things that is present and attached to the player object in the game world is the game's camera, right? So the game's camera is another one, a little bit reminiscent of the light source, that's like a virtual object that represents where the camera of the game is that you, the player, are seeing things through, right? So in the case of a first person game like a VR game, the camera is sitting in the game world, about 1.5 meters above the ground during play, representing what you would see out of the avatar's eyes, where your VR headset would be positioned in the world, right? Now, because it's a VR game, if I expand camera rig one more level, you can see this is where the components of the VR setup get represented in the world. So not only is the camera there, right, which represents where the headset is, but the left and right hand controllers are as well. And if I expand one of those at least one level, you will see that's where, in the case of the left hand, the 3D model that represents the shield is, because it's attached to the controller object. It's and in fact is providing the in-game visuals for the controller object, right? And the
Yeah.
same thing on the right hand, if we do that, you'll find this model which represents the blaster. Right, I don't know if we'll be able to get a good view of it because it's being blocked by some other things here, including the shield. But there is a blast. You can sort of see it there through the white effect of the audio icon, right?
Yep.
And this is how things in the game are represented. I won't talk about what every object here is right now. We'll get to some of it later on. But one other term I want to introduce is everything you see represented in this hierarchy. There's a generic term for those things. They are game objects. Game objects, sometimes just referred to as objects for short, but the term I want you to know is game object, right? A game object is something that is in the game world and in fact has some location in the scene, right? Even if it's something we can't see, like one of those audio sources, right? Or the directional light, it still has a location in the Cartesian three-dimensional coordinates of the game world, right? And that's what a game object is. In part, it's what it is. But we'll talk about some of the other things that happen or you get when you're a game object, if you will, because it's super important to Unity development that you know that term. But for now, you need to know everything that's represented in the hierarchy is a game object. That means it has some physical location in the game world, and game objects can contain other game objects as children.
I would also add that just thinking of a thing in the game as a game object is helpful no matter what platform you're using to do game development. So if you are doing GameStar Mechanic, you can look at the avatars, the tiles you use to build the floor, the enemies as game objects. Even if it doesn't say it inside the platform anywhere, it's just useful to think of it in those same terms, and ditto for the endless mission. If you're a game developer and you're looking at a game that you're building, the building blocks of that game are game objects.
Yeah, I think there's what I would say, just to be really precise about that because again, this is a very important term in endless mission and Unity development. I think Natalie, what you're saying is completely fine as sort of the generic use of that term, right? A game object is any object in a game level, right? I think that's fine. Like that's like a game object with a lowercase g and a lowercase o, right? In Unity and also the endless mission, which is based on Unity, built on top of Unity and designed to teach Unity. Game object, like the brand name game object with a capital G and a capital O, is a very important and specific concept that means you get the object has certain capabilities or properties in the game that we're going to make use of when we code, right?
Absolutely.
So be aware of that difference in usage. But again, I think in the generic sense, Natalie, that's totally a valid way to think about it.
Yeah, it's kind of like what I was saying earlier about the assets, right? Like when we use a more simplified platform like GameStar, you just have this sort of simple set of assets, like crates and floor and so forth. And then in Endless Mission, and then even more so in Unity, we really have more immediate access to what those data structures actually are on the computer.
Yep.
And we have to represent them in a more detailed way, like what you're saying about game objects, and be very precise about their qualities when we're in an environment like this, because knowing their exact qualities and how they function influences how we code and develop using them. So what I like to do is when I'm in a simpler platform, I like to start with that lowercase idea and just generally think of it in that broad way. And then when I'm ready to go into, say, the Endless Mission or Unity, that's when I go back to those definitions and I get more precise and more detailed about them, like what you're saying, and
Yeah.
maybe even do a little bit more research to figure out, like, okay, when you capitalize game object and you talk about that as a technical term in Unity, I need to know exactly what that
Yeah.
means.
I think that's totally valid. We're going to expand on that definition a lot. What I would say is for the purposes of the course and the live stream, when you hear Natalie or I, when we're working in Unity or the Endless Mission, say game object, you should think about the name brand capital G, capital O version of that. And we'll talk more, again, shortly about what that means. So I would like you in just the next couple minutes we have, Natalie, get through all the orientation stuff, which I think we can knock off quickly. So I'm going to go a little fast, but as always, please feel free to jump in if that's
Go
helpful.
for it, Brian.
So when I select some game object in my hierarchy, like I have the player selected now, over here on the far right side of the screen, you will see this panel called the inspector. Again, hugely important concept in Unity. Remember that term, inspector. The inspector shows me a bunch of information about the game object I have selected, right? With the player selected, I see sort of one category of information right now. It's this thing called transform, right? There could be multiple categories of information here in this list going down. There could be so many I have to scroll to see them all, right? Each one of these categories of information, each section you see here, is called a component, right? Again, another hugely important Unity term, component, right? A component gives some typically recognizable logical set of behavior or abilities or properties to a game object. The transform is one component that a game object can have. And in fact, all game objects you encounter in Unity will have a transform because if you remember what Natalie and I said earlier, all game objects are somewhere in the game world. And the transform represents the location of a game object. And we can see that because with this player selected, look, here's his position, and he has X, Y, and Z components that tell me where in the game world he is corresponding to Unity's grid system. So in this case, I can see his position is X0, Y1, Z0, which tells me the location of this game object is at perfectly aligned with the origin position of the game world in terms of the x-axis and the z-axis, and he's 1 unit in our case. We said that's 1 meter. He's 1 meter up from the ground, right? And that's sort of where the center of my player object is. Rotation represents the orientation of that object, again, relative to the Gizmo's XYZ default orientation. You can see it's 0, 0, 0, which means the player, like we talked about before, is perfectly aligned with the rotation axis of the world, right? I could change any one of these values, and the player will rotate around that axis by the number of degrees I specify. So I could turn him 90 degrees around the y-axis by changing this value to 90, and now he's turned, I believe, like that. Well, actually, it's backwards because my camera is mirrored. He's turned like that relative to the axis of the world, right? I'll set that back to 0. And you see I changed that just by manipulating the values up here in the inspector. And then scale represents how big this thing is relative to the default size when it was created, or if it's like a model imported, right? So if I bring in my, let's say we're working on our boss enemy later, and we find a 3D model for it, and we bring it in, and the 3D model is like 1 meter tall, right, at its default scale, and we're like, well, that's not big enough to be intimidating. He's supposed to be a boss. He's supposed to seem really tough and intimidating. We could adjust the scale and change each one of these values to 5, and then he would be 5 times as big, right, as he originally was, and maybe that's good. We don't have to change them all. I could just change the y, in which case he'll look really long and skinny and stretched, right? Or I could change just the x, in which case he'll look very wide. And that's how those work, right? Again, every game object in Unity will have a transform because it has to be somewhere in the game world. Now, there are other components that an object can have. And Unity gives us a bunch of these components, and we probably will interact with many of them as we actually do the project. But if you want your object to be subject to the laws of physics, there is a component that you add, right, called a rigid body. You don't have to memorize these now. These are just examples. If you want your object to be able to collide with other objects, there's a component that you add called a collider, right? There are a bunch of different components you can add. And you can even make components of your own. And so if we go a level or two deeper, I got to find an example of one. Let's see. Okay, cool. I've now selected a game object that's located at the very tip of the blaster gun, right? And this object has a couple of components on it. It has a transform which tells you where in the world it is, right? It has a audio source on it. And what this is doing is that when the blaster is fired, this is where the sound of the laser blast when the player shoots is emitted from in the world. And then it has this thing called fire projectile, which it calls a script attached to it. And this is how your code in Unity makes stuff happen, and where we're going to start next time. Because this component and all the things about it, all the things I can see here in the inspector and change, whatever this thing called speed is, whatever this thing called auto destroy seconds is, right? As well as everything that this actually does, right? And I can tell you that this is the script that knows how when you pull the trigger to actually make the laser blast fire and how to make the laser blast go in the direction that you want it to go. All of that is controlled by code that I've written for this script and then attached to this object, which brings up its components, which makes this component work, right? What code, you ask? Well, if I select that component, I selected Edit Script, you will see in a second, because I should have had this up already, but I didn't, and this will be a good teaser to leave off for today. When this finishes loading, I'll bring it up on the screen for you, but you'll actually be able to see the C# code that is making that component what it is and making it work. Here we go. So right here on the screen here is the C# code that is responsible for the firing behavior and for making that component work. And next time, we're going to get into some actual C# code. In this case, the code that makes the deals with how the damage of the weapon is dealt and how the scoring system works. We're actually going to get into that code, see how it relates to the components, and see how we can actually make changes that change the behavior of what happens in the game. And that's kind of my tease for that. But now you have at least all the terminology you'll need to understand that. And don't worry, we'll see lots of examples of it in action as we progress through.
Sounds like a fun thing to start out with next time,
All
Brian.
right, so you guys are ready to dive into some code and some Unity components and scripts next time. You guys are all primed for it, and I look forward to tomorrow's live stream when we're going to do that.
Yay.
So we will see all of you tomorrow. Have a wonderful evening.